Dear friends, this day we can see how the efficiency of packing can be calculated. What is the efficiency of packing? We have simple cubic system, face-centered cubic system and body-centered cubic system. FCC, in some way we can call it as CCP, cubic close packing, that you have studied in one of the previous class, CCP arrangement. And there you had HCP arrangement also, but there we have told that HCP is equivalent to CCP in efficiency and CCP now equivalent to FCC. So if you calculate the efficiency of FCC, you will get the efficiency of CCP and HCP also. So today we are dealing with simple cubic system FCC and BCC for their calculation of efficiency. You can see a simple cubic system in the picture. Okay. 8 particles touching each other. This is a simple cubic system. Since our constituent particles are spherical in shape, even if we are packing it very closely, we can see lot of vacant spaces between them. In this picture also you can see vacant spaces. In the second picture also you can see the vacant spaces. Here everywhere you can see vacant spaces. So total volume of a cube is a cube, but the entire space of the cube cannot be used for packing. Since the particle is spherical in shape, lot of vacant spaces will come definitely, and packing efficiency is less than 100. Then there is a question: what is the actual efficiency of packing in simple cubic system? For calculating it, first you have to draw the front face of the simple cubic system. Front face is like this. Front face is simply 4 spheres touching each other. This is the front face view of the simple cubic system. This is one face of the cube, front face of the cube. Here this distance is called a edge length, and half of this distance, I mean this one, that is R. So from this figure you can see that this is one R and this is another R. R means radius of the sphere, A means edge length of the cube. So from figure A equal to 2R. Okay. Now what is the efficiency? Total space occupied by spheres or particles by total volume of cube into 100, then it is percentage efficiency. Total space occupied by sphere means what is the volume of a single sphere? 4 by 3 pi r cube. In simple cubic system we have one particle, 8 into 1 by 8. FCC it is 4 and in BCC it is 2. So you can generally write it as 4 by 3 pi r cube, the volume of a single sphere, into number of spheres in a single unit cell divided by volume of a cube is always a cube. In this special case of simple cubic system, it is 4 by 3 pi r cube into number of particle per unit cell is 1 in by divided by a cube. In denominator you have r cube and in numerator you have r cube and denominator you have a cube. So either you can change this radius in terms of edge length a, or you have to change this edge length a in terms of r. Usually we are doing the second one. We have the relation a equal to 2r from equation number 1. When this equation number 1 is put in equation number 2, it become 4 by 3 pi r cube into 1 divided by a means 2r cube. That means 4 by 3 pi r cube divided by 8r cube. Then r cube will be cancelled. For this cancellation we are writing edge length in terms of radius. Then 4 and 2 cancel to 2. Then 3 into 2 6. Then it become pi by 6. That is the efficiency. 3.14 divided by 6. 3 by 6 is 50%. It is somewhat greater than 3. 3.14 by 6 is around 52%. 52%. This is the efficiency of which kind of arrangement? Simple cubic arrangement. Efficiency is 52%. With this we come to the end of efficiency of simple cubic system. If you have been asked the packing fraction, then you can write it as 0.52 percentage, then into 100, then you will get 52. This is the calculation of efficiency. Then one more relation you can see here, that here edge length a is r plus r2r. Then r equal to a by 2. So you have a new relation. Radius in a simple cubic system is half of the edge length. Then you have to see the interparticle distance or nearest neighbor distance. Nearest neighbor distance means തൊട്ടടുത്ത രണ്ട് പേര് തമ്മിലുള്ള ദൂരം from this point to this point, that is a. So you have d equal to a. What is the relation between r and d? D is the double of r. Double of r. It is a by 2. It is a. So for a simple cubic system we have seen three important properties. One is efficiency 52, radius is a by 2, and distance is what d? In previous video you had one d, that is interplanar distance. Here d is nearest neighbor distance, തൊട്ടടുത്ത ആൾക്കാർ തമ്മിലുള്ള ദൂരം, that is one edge length a. Now we are proceeding to FCC. When a simple cubic system changes to FCC, in a simple cubic system you have 1 2 3 4 touching spheres at the front four corners. In face center you have to push a particle into this cavity. At the center of the face you can push a particle of the same size. Then these four spheres move away to give space for that fifth particle. Then it will become like this. So the front view is like this. Okay, you can write here it as one sphere, face centered, again corner, here one corner, here also one corner. Then you can draw that face center, front face. It is A, it is B, it is C. Definitely AB is edge length A, BC is another edge length A. Then what is AC? From Pythagoras theorem, AC equal to root of AB square plus BC square. AB is edge length, BC is edge length, but AC is a face diagonal. Face diagonal means we are drawing from this point to this point. This is a face diagonal. This particle is here, this particle is here, this center particle is here. So this is a face diagonal. How many radius can be seen here? This is 1r, this is r, this is r, this is again 1r. So AC equal to 4r, that is one relation. And from Pythagoras theorem, AC equal to AB square plus BC square, then root of A square plus A square, that is root of 2A square. From 1 and 2, both represent AC. So we can 4r equal to root 2 A square coming out of the root, then A. Now what is efficiency? Number of spheres 4 by 3 pi r cube into number of spheres divided by volume of cube, that is 4 by 3 pi r cube into 4. In FCC we have 4 particles divided by volume of cube is A cube. Then again you have to change A in terms of r. We have 4r equal to root 2A, then A equal to 4r by root 2, that is 2 root 2r. Put this relation here, then 4 by 3 pi r cube into 4 divided by 2 root 2 r the whole cube. 4 pi r cube into 4 divided by 2 cube is 8, root 2 cube is 2 root 2, then 16 root 2 into r cube. And also we have a 3 here, 3 into r cube is cancelled. Here 4 into 4 16, 16 and 16 cancel, and remaining is pi by 3 into root 2, 3 root 2. Then you will get the value 74%. For packing fraction it is 0.74. If efficiency is requested in percentage, it is 74%. So simple cubic system is very weak. It has half the efficiency, 50% of the space is completed. Exactly it is 52.4. But FCC is highly efficient. 74% of the space is filled by particles. This FCC is equivalent to CCP and HCP. Then they are also have the same efficiency of 74%. And the additional relation we can see here is that the relation between edge length and radius. In FCC, we have the relation 4r equal to root 2a. Then r equal to root 2a by 4, that is a by root 2. That is a relation between edge length and radius. 1 radius equal to a by 2 root. Then nearest neighbor distance d, that is the double this distance. This is radius, this is nearest neighbor distance. It is the double of radius. From the figure itself it is very clear. So nearest neighbor distance is double of radius. What is radius? Radius is here. So 2 into a by 2 root 2, 2 and 2 cancel, and a by root 2, that is 0.707 into edge length. So this is 0.707 into edge length. That is the relation between nearest neighbor distance and edge length for FCC. Now lastly we are coming to BCC. In BCC you can see 4 particles. One, two, three, 4, and in the center of the body you can see body centered particle. So you can draw a cube. And particles 1, 2, 3, 4, 5, 6, 7, 8 and 1 at the body center. You can see a body centered cubic system, and we have represented A, B, C and D here. Here AC is face diagonal. AC is face diagonal and AD is body diagonal. Drawing from this to this point, in which you can see the particle in the body center. AC is root of AB square plus AB square. This is edge length, this is edge length. CD is also edge length. AC is face diagonal and AD is body diagonal. So for AC you have root of a square plus a square, root 2a square. AD, what is AD? AD equal to AC square plus CD square, root 2a square plus you will get root 3a square. This is root 2a square, this is a square. So AD is root 3 into a coming out of the square. This is first relation. Then also you can see that AD is, from the diagram it is body diagonal. Here 3 particles touching each other. This figure clear out it. This is 1R, body center you have 2R, and here you have 1R, R, 2R and 1R. So AD equal to 4R from 1 and 2. 4R equal to root 3a and a equal to 4R by root 3, that is 3. As usual we are calculating efficiency equal to 4 by 3 pi r cube into what we have now, we have body centered, then particle is 2 by a cube, then 4 by 3 pi r cube into 2 divided by a cube means 4r by root 3 cube, 4r by root 3 cube, 4r cube, 64r cube into 3 root 3, r cube cancelled, 4 and 64 16, 16 and 2 it is 8, 3 and 3 cancelled, and remaining is root 3 pi by 8, which is 67.9%. We can say it as 68%. packing efficiency is 68% and packing fraction is 0.68. It is somewhat less than FCC. So efficiency of simple cubic system is 52.4. For FCC it is 74 and BCC it is 68%. Okay, and here also you can see the relation between radius and edge length, neighboring distance and edge length. From this relation, for r equal to root 3a, then r equal to root 3a by 4. Root 3a by 4 means 0.433 into a. That is relation between r and a. Then nearest neighbor distance d is double of radius, that is 2 into root 3a by 4, 242, then root 3a by 2, that is around 0.866, double of this number, 0.866a. So you have many relations here, 3 efficiencies and 3 relations between r and a, radius and edge length for simple body centered and face centered system, and also relation between nearest neighbor distance d and edge length a. All these 9 relations you have to keep in your mind for going to competitive examination as well as your theory examinations. Thank you.